Welcome. In this video, we are going to talk about understanding functions as well as function notation, and we'll begin to introduce the concepts of domain and range. So the first thing we want to talk about is generally when we are dealing with functions, we have an input x and an output y. So what I like to do here is think about this as a little bit of a word association. Generally, we think about x as being input and our y is our output. We also could refer to this x and y as letting x be the independent variable. So it's independent. We can choose any variable we want. And then the output y value is dependent on that input. So the y value depends on the independent value x. And the way we generally think about these is that x, those represent our domain, and the y values represent the range. Now, we can use any set of variables, x and y, q and r, a and b. It's just that generally when we're talking about functions, we use x as our input and y as our output. So x, the set of all possible x values or inputs that you can plug into a function, those represent domain. And the set of all the outputs or the y values that you would get out, those represent the range. Now, we have rules, and we'll talk about these in the future, but we have rules for finding domain. When we go to find range, we generally need to look at the graph. And then something else that's really important, we're going to be talking a lot about, and we're going to be using it for the rest of the semester. But anytime we write a set, domain, and range, we're going to use interval notation. Right, so interval notation is going to be super important for the entire semester. All right, and what we want to know is that this correspondence or the relationship between the domain and range, how they talk to each other, that correspondence can represent what we call a function. Okay, so let's talk about what a function is. Our formal definition of a function, well, that says that for each element or member, for each element in the set of the domain, so for each input, there exists exactly and only one element or member in the range, my set of outputs. So for each element in the set of the domain, there exists exactly and only one element in the set of the range. So breaking that down, basically that says each x corresponds to exactly one y. X can only go to one y value. Remember, x are my input and y are my output. So when we start thinking about visualizing what a function might be, essentially what we want to remember is that an x value can only match up to one y. So each x can go to only one y value. We do have an important factor to note, and that is that a y value can correspond to more than one x value. So what does this mean visually, and how do we know if something is a function? Here we have two relationships, two examples, and we want to determine if each x or input value matches up to exactly and only one y value. So if we look at this first example, 3, that goes only to -2. So 3 matches up to one y value. 6 matches up to 5. It goes to only one y. And then 7 matches up to -2. So each x goes to only or points to connects to only one y. So that means that yes, this relationship or this relation represents a function. Now let's consider, given these ordered pairs, this relation of ordered pairs. We have three different ordered pairs. Remember, ordered pairs, x comes first and y comes second. So do each of these ordered pairs all together in this relationship, do they represent a function? One way we might want to think about this would be to write our inputs, our x values. So my x's, I have 3 and -2. And the y values I have here are -2 and 5. So let's think about this. Well, 3 matches to -2, but 3 also matches up to -5. Since this singular x value corresponds to two different y values, we are going to say no, this is not a function. All right, and I could connect to that, put that extra little arrow in there, but that doesn't really make a difference. So one thing you want to notice is that a y can have multiple x's, but an x can only go to one y value. Now, we thought about this, conceptually here with these relationships and literally matching up points. But how can we tell if something is a function just by looking at it? So if we want to be able to look at something and determine if it's a function, this is a visual test, we use what is called the vertical line test. And what the vertical line test says is that if you can draw a vertical line through a graph and it is possible to cross that graph more than once, then what we would say is that that graph does not represent a function. So here are two examples. Maybe we have a curve that looks like this. So regardless of where I draw a vertical line on this graph, I could draw it there, I could draw it here, any of these places. Regardless of where I draw it, it will only cross once. So in this situation, we would say, yes, this is a function. An example of something that might not be a function, if I had a graph that looked like this. Now, it's possible for me to draw a vertical line right here and have that only cross the graph at one point. But if I draw that vertical line over here, you'll notice it can cross the graph at 3 spots. So since the vertical line can cross the graph more than once, this is not a function. So that's going to conclude this video. We talked about determining if a relation or a visual graph is a function. And then we also talked about what it means or the definition of a function. All right, briefly introducing the concepts of domain and range. So connecting all that together, I'll see you in the next video where we talk about function notation.